Welcome to Scratch Lesson 7 using lists and incrementing variables. And as you'll see as we go through this lesson, those two concepts kind of go hand in hand together, and that's why we're putting them together in one lesson. So we're going to start by talking about lists. Lists are really just variables, but variables that can hold more than one value. So it's kind of like a super variable or a variable on steroids, and I'm going to show you what I mean by creating a list here, and we're going to play with it a little bit. So we're going to get rid of the kitty cat. There's no need to have that in this lesson, so we're just going to delete that. And because there's nothing left on our screen here, the only thing that we have really is this object called the window or the backdrop. So we're going to actually program on the backdrop. You'll notice it's blue down here. So that's what we're using. And we're going to create a list. So if you go to data, you'll see that you can either make a variable or make a list. And we're going to make a list. We're not going to use, we're not going to go crazy here. We're going to use a simple list that's going to hold numbers. So to completely use a lack of imagination, we're going to call this number list. And of course it's going to be for all sprites because it's in our stage, in our backdrop. So anything that we put into this backdrop is an object that is part of the stage, and therefore it's going to inherit or have the same access to the same variables that the stage does. So this is why it's going to say for all sprites and don't even have any other options here. So we'll go OK. Now as soon as we do that, you see that we have this number list. It shows us our list here. And it also gives us a lot of programming blocks to go with this list. We can delete things from the list, insert things in the list, replace things, add them, and so on. And we'll try a few of these out to see what they do. Now, like I said, a list is really just a variable that can hold a large number of numbers or quite a few values in it. And I used a very, very unimaginative name for this particular list. By the way, a list is not called a list in other programming languages. Most other languages refer to these as arrays. So in C++ and virtually every other programming language, these are called arrays. But they work on the same principle. They have the same kind of conceptual design regardless of the language and regardless of what they're called. So Scratch calls them a list. So in this list, I'm going to put some numbers. And again, because I'm going to be completely unimaginative here, I'm just going to put the numbers, I don't know, 1 through 10 or something in here. So I'm going to populate my list by adding numbers to it. So let's start off by making an event. Let's go when A is pressed. A will represent add. So we're going to add a number to our list. And we're going to actually have to have a number that we put in here. So let's make a variable, just a regular variable called number, that we're going to use to store a number in that we're going to add to our list. So number is here on my screen. I'm going to move it over to here so there's room for it. And when I start my program off, so when this green flag is clicked, we're going to set our number to 0. So every time we start our program, number is 0. Okay, and that's just a way of initializing a variable so that we know what it is when we start our program, and that's also good programming practice. Now, under here, when I press the A key, I'm going to go back to my data, look down at my list, and simply add something to the number list. Well, I want to add this number to the number list, and therefore I click on the number variable, put it in place of thing, and now this number will be put into my list. Since there's nothing in my list to begin with, the value 0 will go into the first position in my list. And every time I press A, it'll keep adding the very same number, 0, to my list. So let's just do that and see what happens. So I'm starting it off. I'll press A, and you can see the number 0 is being put into my list. If I press A again, it will also still put the number 0 into my list, but it will put it into the second spot. So you see in the second spot, the number 0 is being put in again. And I keep hitting A, and I keep adding 0 to my list. Now, I can't imagine a more useless array than what I just created, because all it has is the number zeros in here. And by the way, while we're looking at this, we'll look at some of the terminology. This list has elements. Each of these horizontal boxes is an element of my list, and each element has its own number. So this is the first element of my list. My second element is here. The third, fourth, fifth, and sixth elements of my list are here. Each element contains a number, and that number is a really astounding 0. Okay, let's make this hold some different numbers. For example, let's make it so each number in the list goes up by 1 each time. That's called incrementing a variable. So I'm going to do this. I'm going to go set number, put it underneath this event where I press the A key at the very end here. And I'm not going to set it to 0 because frankly that's exactly what it did to begin with. That's boring. But let's do this. Let's use the addition operator and say number is going to be number plus 1. Now this little piece of code right here is as kind of plain as it looks, is actually a really important programming ideology or programming concept. This is called incrementing a variable. This is how we make a variable go up by a certain amount each time we call it. And in this case, we're making it go up by 1 each time. So what's happening? The variable number will take whatever it has in its, whatever it's storing right now, and by the way, number at this moment is 0. So we'll take 0, add 1 to that, which of course will equal 1, and then take that result and put it right back into the variable number again. So what happened to the 0? Well, it's lost. So the 0 is gone now, and to replace it is 1. The next time you go through here, it will take the value 1, add 1 to it, and now it will store 2 in here. And if it comes through a third time, it will do this. 2 plus 1, it will be 3. So each time I press the A key, number is incremented by 1 and goes up by 1 each time. So let's clear out these values. I haven't showed you how to do that yet, so let's go about clearing out this array so we can start all over again. I'm going to make an event when I press the D key of actually deleting. That's why I use the D. I'm going to delete all the elements of my array. And sure enough, if I go back to my array list of blocks here, there is a delete feature, or delete block. I can put it here, and you can choose to delete one item, the last item, or actually this is the first item, this is array element 1. The last item are all the elements, and I want to choose all. So as soon as I press the D key, I'm going to delete, boom, all the elements of my array. So I wiped it clean, and I'm ready to start again. So if I click my green flag, my number is set to 0, and you can see it's 0 here. Then when I press A, let's think about what will happen before we actually do it. If I press A, it'll take number and put it into my list in the first spot. So it will create a little element. The first element will hold the number 0. Here it goes. Boom. But it went to this next piece of code, and now it took the number, which was 0, added 1 to it, and put the result back in the same variable number. So now it should hold the number 1. And if I look on my screen, sure enough, the variable number has the value 1 in it. So if I go back and hit A again, it's now going to put 1 into my number list. It's going to add to it, so it's going to create a new element and put 1 there. So there it is. It now added 1. But of course, it goes to here, it goes 1 plus 1, and number is now equal to 2. And I'm incrementing my number variable by 1 each time. So every time I press A, this value will go up by 1, 2, 3, 4, 5, 6. Therefore, I've basically incremented my variable number and placed it into my array. And each time I press the add key, it just keeps putting more and more numbers in my array. So there it is. If I can look at them all right now, I've got 13 elements in my array, and I'm holding the values from 0 to 12. Okay. Again, that's kind of boring, to be honest. That doesn't really do much, but the purpose of this lesson is to show you how to use an array, and later we'll actually use array for something more valuable. Arrays will have many, many different uses, and we'll get to those shortly. So if you're patient and just understand how to manipulate an array. We'll go to some useful features of arrays down the road. Okay, so let's say I actually want this to jump by 2's. How could I do this? In fact, I want to do two things. I want to start not at 0. I want to start at 1, and I want it to go up by 2 each time. So if you want to pause the video and think about that, or try that as a kind of a challenge for yourself, do that and then come back and I'll show you how I do it. Okay, so how would I do this? I'm going to first set my number to 1 so that when I press the A key, it's going to start at 1. So let's try that. I'm going to delete my elements in my array. Boom, there they go. And now if I put the D in here, and that's a mistake I often do. I change a value in a variable, and then I go ahead and I press a letter because I think I'm going to be actually running my program. But I've actually put it in here, and that screws things up. So I press 1, click out of here, and then when I press D, I cleared my loop, or cleared my array, excuse me. And then I'm going to come back to here, press A. It's going to put the number 1 into my list to begin with. And whoops, there's 13. How did that happen? Well, let's take a look. Oh yes, number was not set back to 0. So when I click my flag, number should have been set to 1 here. Let's try that again. There we go. And let's clean off my array, hit the D key, and let's try one more time. So when I press A, here, I pressed it twice, I'm screwing it up. I'm going to stop, clear this out, press D, try one more time. If I press A, there it is. The first element has the number 1 in it. Okay. If I press again, it'll have the number 2, but I asked you to go up by 2 each time. So if you thought about it, you would have come to here and you would have simply increased this to 2. And so then this time I'll have the number 1 in here, add 2 to it, it's going to be 3. However, I didn't change this in time, so I'm going to reset my program, clean off my array, and try it one more time. So now when I press A, I'll add the number 1 to my list. There it is. Then it takes number 1, adds 2 to that, stores it back in number. When I press A again, number is now 3, and it's going to add 3 to my list. And then of course should be 5, 7, 9, 11, and so on. And there you go, you're going up by 2 each time. So here's something else we can do. Instead of adding by 2, let's clean off our array, D, to delete my array. Let's set the number back to 0, so I'll press the green flag to set my number to actually 1, which is fine. And instead of adding by 2, let's try this. Let's throw that operator away and put the multiply in here. Put number back in and go times 2. Can you think what's going to happen this time? Starting off with number 1, it's going to place the number 1 in my array. Then take 1 and multiply it by 2, which of course gives you 2, puts it back in number. So next time through it'll put 2 into my list. So let's go A. Let's just try that and go A. 1 goes in here. Press it again and the number 2 should pop in here. Then it takes 2 and multiplies by 2 and gets 4. Notice how number is now 4. So it's going to put the number 4 in next. Takes 4, multiplies by 2, and puts in 8. You notice how it's doubling each time? Well, that's exactly what this is doing for me right here. It's multiplying by 2 each time and putting that resulting number into my array. And for those of you who've looked at binary and know a little bit about binary, this is how the place values in binary go up. The place values in binary are really powers of 2, and you're multiplying by 2 each time. So 1, 2, 4, 8, 16 are the place values of binary, and that just is a coincidence here. I didn't intend to do that. And so as you see here, I can keep going up and up and up and get to some really large numbers. This is also increasing exponentially, which is an exponential growth. So there you have it. I'm going to delete those numbers from here because frankly that doesn't do me any good. I'm going to go back and just go add again so the numbers stay in a reasonable range, easier for us to look at and understand. Let's go up by 1. Clear it off so number resets to 1 and go add, and I get these numbers in here like I thought I would. So the number that we use to represent each element, this 1, this 2, this 3 here, not the actual values, but the numbers are called indices, or they're the index of the array. So if I say number list index 4, I'm actually at the 4th position of my list, and that 4th position actually so happens to have the number 4 in it right now. Okay? Index position number 7, or element 7, is right here, element 10, and so on is right here. So let's say I want to leave my list more or less as it is, but I want to replace just 1 or 2 numbers in this list. I'm going to come back to data, and of course there's a feature for that, which is replace. So let's say if I hit the R key, I want to replace something. So when I press the R key, R will mean replace. There it is. Then I'm going to replace, well, let's ask the person, the user, which element they would like to replace. So to do that, I'm going to make another data variable called index, because this will represent the index of my array. And I'll click OK. It's set to 0. That's just fine. In fact, just to make sure it's set to 0 every time my program starts, I'm going to put it right here at the beginning. So I've initialized index to be 0 whenever this program starts up. And I'm going to ask the user which element of the array they'd like to replace. What element of the array, or actually the list, remember they're both the same thing, would you like to replace? Question mark. And of course, if I ask a person a question, I need to get the answer. So under sensing, I'm going to set my index to the answer. So I'll go here and I'll say set my index to whatever the person's answer was. So if the person said they want to replace element 7, my index is now going to be 7. Of course, whoops, I'm putting that in the wrong spot. Let's put it right under R key. And then I also want to ask them what number they'd like to put in its place. So I'm going to ask them again, what number would you like to use, or what number would you like to enter? Okay, and of course, in this case, I'm going to make my number equal to their answer. So I'll go back to data and say set number to the answer. Now I have the information I need. I know which position in my list I want to go to, and I know what value I want to put into that position. So now I'm going to go replace the item index, so it knows which value here, or sorry, which location to go in my list, and replace it with the number that they have entered. So let's give this a try and see how this works. So I'm going to clear everything off, hit my flag, so my index is 0, my number is 1. As a matter of fact, let's set number to 0. Usually if you're going to start a program off and you're going to create a value or a variable, we usually initialize it to 0. So there they are. I need to clear off this list, so I'm going to hit D to wipe out everything. Let's add a few numbers to it. There it is, by using this routine, which I haven't changed at all. So there are the numbers in my list. And let's say I want to replace element 7. So the value 6 sitting in here right now, I want to get rid of. So I'm going to hit the R key. What element of the list would you like to replace? I want to replace element 7. So I'll type in 7 and enter. What number would you like to enter? Let's pick an exciting 23 and hit enter again. And sure enough, in list position 7, the element 7 is the number 23. Try again. Let's do it to element 10, and let's put in 14. There it goes. Now let's try something that should cause a problem. Let's ask to replace element 12, which, if you're being observant, doesn't exist. So I'm going to put it in here. The computer doesn't check if it exists or not, and I want to make the value 15. So it's asking me this, so I'm going to hit 15, and this would normally cause a real problem in most other programming languages because the computer would look for the 12th position of the list, not find it, and freak out, and it'd have an error message. Scratch is actually what we call a high-level programming language, or a scripting language, which anticipates possibilities like this and doesn't crash. So actually that works to our benefit. In other lower level languages, you would have to program in the possibility that a person enters an element number that doesn't exist and deal with that accordingly. If you didn't take it into account, your program would probably crash. Definitely trying to access an element that is outside the range of your list will cause huge problems in most other programming languages. Now, just before we finish, I want to show you that something else is interesting here. I've populated this list with these numbers. If I save my program and quit it, then come back later, will that list with its numbers still exist? Well, let's try it. I'm going to open Scratch. I'm going to open up that program I just had, which is in my D drive under Computing Science and my tutorials, and there it is. If I open it up, sure enough, these values are still there, which is actually an advantage. If you're programming and you're populating an array with numbers that you need to use, you do not have to continue to repopulate this list with those numbers when you close your program and open it back up again. You can always reinitialize or delete your list by having this delete statement in here, so every time you start your program it deletes. That's a possibility, but most of the time when you take the time and effort to populate a list with values, you probably want to keep those values. So that's just a very quick introduction to lists. It's also a very quick introduction to incrementing a variable, which I guarantee you will use in the future quite often, regardless of what you're doing. And later on we'll get to look at actually why we create lists and what value they have to us as a programming language. So thank you for listening, and tune in for the next lesson.